Hello, so this is the video for the third term project, which will use some of the stuff we were talking about earlier in the year, and I wrote a little Maple program to help illustrate what we were looking at. So earlier we were talking about the two different equations for motion, the Jeff-Cott rotor, and those are the same equations we're going to be looking at here. And here we're going to try and see what happens over a certain range, what happens to the oscillation, the vibration, giving certain parameters. And maybe if we were going to change the parameters, what would the output change like? So, hope you can see, initially we have two equations. One's for the x and the z in this case, because that's where the system, the rotor, is rotating. And we have initial conditions for both, so we have DE1 and DE2, and then I was only looking at DE1 here, so the initial conditions for the first one, where I set the derivative to 0. And then down here I set the mass equal to 1, I set the stiffness equal to 0.1, the damping equal to 0.01, and then the distance from the center mass, I gave it a value of 0.5, and then let omega be 0.25. And these were similar values to we used in the first homework. So then when I solved, I put in the Maple to solve the equation. I'd output that, and then I wanted to look at it from the initial period, so 0 to 300, and then 0 to 1500, using the initial inputs I used. And then what we have here, the first one is from 0 to 300, the second one's from 0 to 1500. At first it hasn't become steady at all, it's still varying, and then once you get up to probably somewhere in the 400s or so, it begins to stay at steady state and stays constant over the remainder of the time. And if we were to change any of the initial conditions that we had used, so say we had changed the distance from the center and made it shorter so that it was actually vibrating less, the output would reflect that, and then the oscillations would be less, so therefore it would become more stable. And if it was greater, then the system would become more unstable rather, and the magnitude of the oscillation would be larger if that happened to be the case.